Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing pressure paper 2 for extended candidates only. We have an assessment, 25 questions, 40 minutes, and we have to start by KWL chart. You have to write down what do you know about pressure, what you want to know about pressure. At the end, you have to write down what you learned. Let's start by question number 1. Question number 1 is discussing a solid block is resting on a bench. You have the dimensions are shown on which labeled surface should the block rest to produce smallest pressure. Back to the equation used to calculate pressure. Pressure is equal to applied force divided by area of contact. In this case, the applied force is the weight of the block, which is constant here. So the weight of the block is constant. Pressure is inversely proportional to area of contact. You are looking for smallest pressure. It means the area of contact will be largest. So you have to exclude Q. It's clear here, Q is the smallest area of contact. So you have to compare between face P and face Q. Face P, when you calculate the dimensions, the area of contact, P, so it's 80 times 40. This is 40. Also, this is 40. Okay. Face R, it's 80 times 20. So this dimension is 20. So it's 80 times 20. Without any calculations, it's clear that face P is the largest area of contact. So the correct answer is A. Pressure due to liquid depends only on the vertical depth of liquid, not on the cross-sectional area or the width or shape of container. So section X and section Y, they are having same pressure since they are including same type of liquid, same density of liquid, and same depth of liquid. The reference is pressure due to liquid is equal to rho GH. Density of liquid, it's a factor. Depth of liquid is a factor. But the shape of the container and this dimension, section X and section Y, this is not one of the factors affecting pressure due to liquid. So the correct answer for this one is C. Pressure on section X equals pressure on section Y. Question 3, we have an object is 60 centimeter below the surface of a liquid. The pressure due to liquid at this depth is given 9,000 Pascal. What is the density of liquid? Pascal is a unit for measuring pressure equivalent to Newton per square meter. Okay? And this unit named after the scientist and French mathematician Blaise Pascal. You have to check first that you have consistent units. So when you substitute here, you have the equation, the pressure difference is equal to rho GH. So density is unknown. When you substitute Pascal, you have to convert depth to meters. 60 centimeters should be converted to meters. So you have to multiply by 10 to the power of negative 2 or divide by 100. So G is equal to 10. You have 60 times 10 to the power of negative 2. Simplify. Your answer will be, so you can cancel out your answer will be 1500 kilogram per cubic meter. Your correct answer will be C. Question 4, we have a pipe full of water connects a water supply on a hill to a tap lower down the hill. The length of the pipe is given, density of water is given, the height of the supply is given, the effect of atmospheric pressure is negligible. What is the water pressure at the tap? Since here we are calculating pressure due to water at the tap, so we are considering the vertical height above the tap only, which is the height of the supply. So in this case, applying our equation, delta P is equal to rho GH, density of water is given, times G times 100 meters only, which is height of water, the vertical height of water above the tap. Okay, so the final answer will be one million Pascal, which is the answer here is C. The correct answer is C. We can use prefix to write it as 1 megapascal. Mega means million, means 10 to the power of 6. Question 5, we have a skier is standing still on a flat area of snow. The weight is given, the total area in contact with the ground is given. What is the pressure exerted on the ground by the skier? Here, simply you have to substitute using and applying the equation. Pressure is equal to applied force divided by area of contact. Just check you have consistent units. The weight of the skier is 550 Newton and the area is given in square meters, which is 0.015 square meters. The final answer is 37,000 Newton per square meter. Your correct answer is D. Question 6 is challenging and is very important. We have a cylinder partly filled with two liquids. these two liquids do not mix and they have different densities. Remember, density, it's an intrinsic property. Each liquid, each material has its own density. It's a physical property. A student measures the pressure due to liquids at different depths. We have position P and position Q, and we have two liquids with different densities. In this case, as shown, you can guess that the liquid here at the bottom, the one at the bottom here, is denser. So this liquid is denser liquid. Okay, and the one floating, it has less density. Which graph showing how the liquid pressure varies between positions P and Q? First of all, you have to remember the factors affecting pressure due to liquid. Pressure due to liquid column depends on the vertical depth of liquid and density of liquid. So pressure due to liquid depends on rho GH, density and depth. In this case, we are representing on the graph tells a story. Remember, graph tells a story. Here the story is discussing the relation between pressure and depth. In this case, we have to exclude D, because D, it's a graph showing that there is no change in depth. And the relation between pressure and depth will be directly proportional, like here in C, just in case that you have same density. And in our question, the density is changing. So now you can understand why we exclude C and D. So you have to compare between A and B. So the gradient or the slope is equal to delta P divided by delta H, which is density times G. Okay, so we have two sections, this one and this one, according to position P and Q. Okay, which one is denser liquid? Denser liquid is the one at the bottom, at position Q. So the steeper the line is representing greater slope, which is equivalent to density. Okay, so steeper line representing greater density, at the same time in our question is representing position Q because it has denser liquid. So the correct answer is B. Question 6 is very simple. A column of liquid has height h, mass m, density rho. The gravitational field strength is G. Which expression gives the pressure due to liquid column? Rho GH. So the correct answer is D. Question 8. We have a wash basin has an exit pipe and it's covered with a plug of area 12 square centimeter. A chain is attached to the center of the plug. The wash basin contains water to a depth is given, density is given. What is the force acting on the plug due to water? First, we have two steps here. You have to calculate pressure due to water column And then you can use the equation pressure is equal to force divided by area of contact, because the plug is a solid surface. So the first step, you have to use delta P is equal to rho GH. Substitute, density is given, check you have consistent units, G is known, and depth is 0.080 meters. So the final answer is 800 Pascal, which is the pressure due to liquid. Okay, when you apply pressure is equal to force, applied force divided by area, so you are here looking for the force acting on the plug, and the plug here, it's a solid object. You are dealing with a solid object. So when you rearrange, force is equal to pressure times area. Force is equal to pressure times area. Pressure is 800. Here the area is a square centimeter. You have to convert to square meter. Use scientific notation. Multiply 10 to the power of -4. So your answer is 12 times 10 to the power of -4. Your final answer oh 0.96 Newton. So your answer is A. Question 9, we have here the pressure due to liquid on an object immersed in liquid is 4,500 Pascal. The density of liquid is given. What is the depth of object below the surface of the liquid? Back to the equation, the pressure difference is equal to rho GH. Okay, so you have to substitute, check you have consistent units. 4,500 Pascal, density in kilogram per cubic meter. When you calculate depth will be equal to, when you rearrange, your answer will be 0.5 meters. Here you have 0.5, but you have 0.5 centimeter. If you choose A, your answer will not be correct. And also, your answer should be realistic. The object will not be below the surface of liquid 0.5 centimeter. So, the object is immersed 0.5 meters, which is equal to, since you have here all choices in centimeter, convert to centimeter, multiply by 10 to the power of 2. So your answer is 50. 50 centimeter is the correct answer. This question is challenging. Question 10. Here we have graph. Graph tells a story. We have identical toy bricks are placed on the top of another to make a tower on a table. Which graph showing the relationship between pressure P that the tower exerts on the table and the weight W of the tower? Okay, Back to the factors. Here we are not talking about liquid. We are discussing here pressure due to solid object on a surface. So the factors we have, applying the equation, pressure is equal to force divided by area of contact. Which factor here is constant? Is the base area, the area of contact. So area of contact is constant and pressure is directly proportional to the applied force. So increasing the weight will increase pressure. In this case, the applied force is the weight of bricks. So which graph is representing the correct relationship between pressure and weight? They are directly proportional, so the correct answer is D. Question 11 is challenging and is very important. A submarine is 20 meters below the surface of the sea and the pressure due to the water at this depth is P. On another day, the submarine is 26 meters below fresh water, below surface of fresh water. The density of seawater is 1.3 times density of fresh water. We have to apply the equation, substitute, and find what is the pressure due to the fresh water at depth 26. First of all, let's write down the ratio, which is very important here. Rho density of sea, the ratio between density of fresh water is equal to 1.3. Okay? When you substitute pressure due to seawater divided by pressure due to fresh water, apply the equation. So let's substitute pressure of sea, density of sea water times G times depth. Depth here, let's write times H due to C. Density of fresh water times G times depth due to fresh water. Okay? Let's simplify and rearrange. When you simplify, this ratio is given as 1.3. You can cancel out G times depth due to C is 20 meters. Depth due to fresh water is 26 meters. Your final answer is 1.3 times 0.77, which is 1. So this ratio is equal to 1, which means pressure due to fresh water is equal to pressure due to sea water, which is equal to P, as written here. Okay, so the correct answer for this one is P. Pressure of seawater or due to seawater is equal to the pressure due to fresh water, which is equal to P. Question 12, we have 4 identical submarines. P, Q, R, and S are lowered from one depth to another, and the water has constant density. The initial and final depths are shown. Which row is correct for the difference in pressure from the initial to final depth for each submarine? The least change in pressure and the greatest change in pressure. Back to the equation, the pressure difference is equal to rho GH. Since here the density is constant, so the factor which is changing is depth of liquid or depth of submarine. So it means you have to compare the least change in pressure or greatest change in pressure according to the change in depth. So least change or greatest change, it means pressure is directly proportional to depth at constant density. Okay, submarine P, you have here 20 meters change. Submarine Q, also 20 meters change in depth. Here you have submarine R from 10 to 50, 40 meters change in depth. 30 to 70, 40 meters change in depth. So the correct answer is A. We have submarines P and Q. They have least change in pressure. Submarines R and S, they have greatest change in pressure.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.